As a third example of using machine learning to simplify rule-based systems, take Netmarble. Netmarble is a leading video game publishing company based in South Korea that develops multiplayer games. Video games are a big business with a total revenue greater than $100 billion worldwide in 2018. For gaming companies, it is extremely critical to retain game players in a fair environment so that players feel comfortable enough to invest time and money into the games. Game abusers can destroy the trust of other users, and Netmarble was using a rule-based engine to detect those game abusers. But this system wasn't meeting performance expectations. To understand why, think about some of the ways that people cheat in video games. Bot players are users that play consecutively for unrealistically long times or with abnormal patterns that are very repetitive or focused on very limited stages. Playtime hackers are users that finish the game unrealistically quickly, for example, without killing the enemy or the boss. Damage hackers are users that modify the characteristics of the hero to have unrealistic statistics such as damage or attack speed at a certain level. And reward hackers are users that get an unrealistic amount of rewards or have usage larger than their income. Now, we cannot use rules like if the playtime is greater than 24 hours, it's a bot to identify abuse, because that's going to net a whole bunch of really innocent people. We have to identify patterns of behavior. So we work together with Netmarble to help them create a machine learning model. The idea is to train the machine learning model to predict user behavior. The machine will learn the probability of certain actions in certain situations over all the games ever played. For example, say that most players progress through a sequence of actions. The model might learn the probability of the next action given the prior actions. And in this graphic, each shape represents an action that a player can take, and the arrows represent possible transitions between actions. The width of the arrows encodes the likelihood of the transaction. From this diagram, it is clear that although it's possible for players to skip from action 1 to action 4, it is very unlikely. Players with behavior totally unlike what is predicted by the model are flagged as suspicious, and the information is sent to humans for evaluation. The pilot project to identify users who were behaving abnormally led to a plethora of machine learning applications within Netmarble. By predicting various users' behavior and adopting multiple modeling for cold users in the game, Netmarble can market games and in-game services to users better. It can also predict churn, players who are sure to leave within a week, players who will remain, and players who need to be managed. It also analyzes factors causing the churn and can hopefully improve things to reduce the churn. So Netmarble also discovered that it could use machine learning to detect fraud. To learn more, check out Netmarble's presentation at Next in the resources of this course. So the key idea here is to do a pilot project, and that success will embolden other departments to carry out their own machine learning projects. Be the pioneer.